Hi students, in this video we are going to study about acoustics and ultrasonics, which is our fourth unit. First of all, we are going to discuss about acoustics. As earlier classes we discussed that the light which deals that known as optics dealing with the sound is known as acoustics. Let us see what is the acoustic. Okay, so acoustic is a science. It is also a science which deals with the sound. Okay, so acoustic is the science of sound and deals within the origin, propagation and auditory sensation of sound. Now, the study of sound plays a very important role in various branches of engineering and has developed to such a level that it has become an independent branch of engineering that is known as a acoustical engineering or sound engineering. Okay, so the design of buildings, auditoriums, music halls, lecture halls, recording halls, etc. Those are known as architectural acoustics. Let us see what is the sound. Now, the sound always produced by some vibrating body. That means where should we are getting a sound? It is always from a vibrating body. Now, the vibrating body excites the mechanical waves in the sound surrounding medium. So, whenever the vibrating body excites, the mechanical waves in the surrounding medium will produce. So, these mechanical waves propagate in air in the form of a series of compressions and rarefactions of air molecules. Okay, so sound can't travel in vacuum and requires the presence of elastic medium for its propagation. So, it can't travel in vacuum, so that's why sound always needs a medium. Okay, so it requires the presence of elastic medium which propagates through the sound for its propagation. Sound waves or longitudinal waves, we already know about longitudinal waves and transverse waves. Okay, so a sound wave is a one complete cycle of pressure variation. So sound wave, each sound wave represents a complete pressure variation. Let us see what is the sound velocity. So the velocity of sound is not a constant and it depends on the nature and temperature of the medium through which it travels. So the velocity of sound, that must and should depends upon the nature and temperature of the medium through which it travels. So in general, the velocity of sound in gaseous medium, that is given by B equals to root of B by rho, where B is the bulk modulus of the medium which we are considering for the sound wave propagation of that medium. Okay, and next rho, that is the density of the medium. We know that density is a mass per unit volume. Okay, and next, so see here there is one note point. What is that? Sound travels faster in liquid media than in gaseous media and much faster in solid media. That is medium and speed. See, air that has a 344 meters per second, pure water that has a speed of 1480 meters per second, and aluminium, it is also has a 5150, there is a meter per second. Okay, so there's a whenever the sound travels faster than in the liquid medium than in the gaseous medium. Next, let us see what is the loudness. Loudness signifies how far and what extent the sound is audible. So it is a subjective perception because of the varying sensitivity of the because the varying sensitivity of the ear, different people perceive the same sound differently, isn't it? So general people will hear the sound at some levels. Deaf people, those are observe the sound at different levels. Okay, so the perceive, each person, different people perceive the same sound differently. So an objective measure of loudness, that is a sound intensity. So let us see what is the intensity. The intensity of sound wave is defined as the rate of flow of sound energy through unit area normal to the direction of propagation. So intensity is nothing but the intensity of sound wave that is defined as the rate of flow of sound energy through a unit area normal to the direction of propagation. That is, the sound intensity level is measured in bells. Actually, the basic units for sound energy is bells. We are considering that in decibels. Okay, so let us see what is the bell. The relative intensity between two sound notes if one is 10 times more intense than another. Okay, the relative intensity between two sound notes if one is 10 times more intense than another. The unit of bell is large and in practice a smaller unit decibel is used. Okay, so 1 decibel equals to 1 by 10 bells. Okay, so some typical sound levels. Here is the source of sound and what is the sound level is. Okay, you just go through it and we have to discuss about the reverberation, which is the main topic in this chapter. Okay, do you have ever the word reverberation? Do you know the meaning of reverberation? Let us see. The existence of sound in the hall even though the source of sound is cut off. That is called reverberation. And repeat it again. The existence of sound in the hall even though the source of sound is cut off. That is called reverberation. So reverberation means the rolling of sound in a hall, within a room, within a specified area. Okay, so when a sound pulse is produced in a hall, it is reflected into a large number of times by the objects present in the hall and walls, so that a series of waves of decreasing intensities fall on the listener's ears. So we are hearing the sound continuously even though there is a decreasing intensity of sound waves. Okay, so hence observer doesn't hear a single sharp sound but a roll of sound. So that is the pulse is heard for a short definite interval of time. So this effect is known as reverberation. You just see here how the reverberation will be. Whenever a person is talking, the sound is direct. So this is the direct path of the sound and these are all the reflective parts of sound. How the reverberation will be produced, you have to understand through this picture. Okay, and next note, here is also a note point. The reverberation of sound pertains to enclosed spaces only. In open air, the sound spreads out in all directions without repeated reflections. That means what happens here? Whenever the reverberation occurs, it occurs only to the enclosed spaces only. In open air, according to open air system, the sound spreads out in all directions without repeated reflection. There may be reflections but not a repeated reflections. Okay, let us see what is the reverberation time. So the time taken by the sound in a room to fall from its average intensity to inaudibility level, that is known as the reverberation of the time. We know that what is the reverberation means? The reverberation means the rolling of sound within an enclosed area. So the time taken for a reverberation is known as reverberation time. That means the time taken by a sound in a room to fall from its average intensity to inaudibility range, whenever the sound is completely dead. So the time of reverberation is known as the reverberation time of the room. Okay, or the time taken by a sound to fall to 1 million of its original value after the source of sound is cut off. So whenever the source of sound is cut off, we are hearing some sound, that is the reverberation. So whenever the original sound, the value of sound that falls 1 millionth of its original value, that is said to be reverberation time even though the source of sound is cut off. Okay, that is the I final, that is what we are using, the sound intensity. I final by I initial equals to 10 power minus 6. So we can express reverberation time in terms of sound energy level, that is in decibels, as follows. So if the initial sound level is Li and of final level is Lf, then see what's happening. We know that Li equals to 10 into log of Li by L. Sorry, I intensity. Okay, initial final. And next LF, that equals to 10 log IF by I intensity, that means intensity total. So Li minus LF equals to 10 log II by IF, initial intensity by final intensity. Now that value becomes 10 power 6. Then Li LF equals to 10 into log of 10 power 6. So completely initial time minus final time, that equals to 60 decibels. So the reverberation time is the period of time in seconds which is required for sound energy to diminish by 60 decibels after the source of sound is stopped. So at what extent we are hearing the sound means after diminishing the sound energy, sources of sound, we are hearing the that will diminish by 60 decibels. Okay, and next let us see what is the sound absorption. When sound incident on the surface of any medium, it splits into three parts. Okay, I am repeating again. When sound is on the surface of any medium, it splits into three parts. So one part is reflected from the surface and another part gets absorbed in the medium, while the remaining part is transmitted through the medium and emerges on the other side. Now, the property of a surface by which sound energy is converted into other form of energy, that is known as a absorption. So, what is meant by absorption of sound energy? The property of source, the property of surface by which sound energy is converted into another form of energy, that is known as absorption. Here also a note point, let us recall. So the fibrous and porous materials absorb the sound energy more like a sponge, so which is a porous material, than other solid materials. Okay, now let us see, we know that absorption. Now what is the absorption coefficient? The absorption coefficient of a surface or a material, that is the ratio of sound energy absorbed to the incident sound energy. Okay, absorbed energy, ratio to the absorbed energy, and what extent, what the initial sound we are incident on a surface. Okay, so let it be A, the absorption coefficient be A, that equals to the sound energy absorbed by the surface to the total sound energy incident on the surface. Okay, clear? Simply this is about the sound absorption. And next let us see what is the open window unit. Okay, so in order to compare the relative efficiency of different absorbing surfaces, it is essential to select a standard in terms of which all surfaces can be described. So a unit area of open window is selected as the standard which we are used to incident the sound energy. Now the entire sound incident on an open window is fully transmitted and none is reflected, because it is a open area, open space. Whenever the reverberation occur only within the enclosed space only. So for that open area, open window area unit, there is no sound to reflect, fully it is transmitted. It is considered as an ideal absorber of sound. Okay, so there's the unit of absorption is the open window unit. So units of absorption is a open window unit, after which is named as Sabine. Okay, again here is a coefficient, sound energy coefficient, that's A, sound energy absorbed by the surface by sound energy absorbed by a open window of a same area. So now the A value depends on the nature of the material as well as the frequency of sound. So the absorption coefficient, that is also depends upon the nature of the material and also the frequency of sound which we are incident on it. Okay, some type of materials and absorption coefficients of some materials is here, you have to go through it. And if the material has a surface area of S square meters, the total absorption provided by that material is A, that equals to absorption coefficient into the area which we are considering, that units are Sabines. Okay, so if there are different materials in a hall, Then the total sound absorption by the different materials is given by A equals to A1S1 plus A2S2 plus A3S3 and so on, because S1, S2, S3, those are the areas which we are considering for the propagation of sound, and A1, A2, A3 are those are the absorption coefficients depends upon the different materials present in that particular area. So all the three terms, that means all the terms, all the things which are present in the room, that is also combined, there has a absorption coefficient A, that equals to summation 1 to n A n S n. That is depends upon the absorption coefficient of each material and area occupied by that material.